Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy, and welcome to our next episode of Trig on Tuesday. Now, you recall last week, I went ahead and did sine and cosine. Today we're going to talk a little bit about tangent and how we use it in practical life. We'll also touch on sine and cosine again, just to make sure that everybody's fresh with it. So let's cue up the music and get going. Well, let's go over what we started in our first episode real quick. Now, if we take our triangle, which is a 3, 4, 5 triangle, that's a right angle right there. We know the lengths of those sides. Now, what is the sine of this angle right here? Well, the sine is the opposite over the hypotenuse. Sine is opposite over hypotenuse, and it'll be 3 over 5. Cosine is adjacent over hypotenuse. Cosine adjacent over hypotenuse, 4 over 5. Tangent is opposite over adjacent. Tangent opposite over adjacent, and in this case it's 3 over 4. This is what you get the old adage SOHCAHTOA from, and that's something that we learned in middle school. I don't like to use it because I just like to be able to understand exactly what it is, and I don't have to think about it anymore once I've learned it. Now remember also, in our last episode we talked about the fact that tangent is actually the sine over the cosine as well, and we showed it from the values for this triangle. Well, let's find a practical use of the tangent. Here it is. Say we want to find the height of this building. Now, say we know this distance right here, and we know this angle, but we don't know the height of the building. Tangent is the opposite over the adjacent. So tangent will be this over this. We don't know this, we do know that, and we know that angle. So by finding out what the tangent of that angle is, we can find the opposite leg. And all we have to do is just rearrange this equation right here. So tangent angle alpha times the adjacent, which is the distance from where we measured to the center of the building, equals opposite, which is the height of the building. Pretty simple to do. Now, to give a practical example of this, say angle alpha is 45 degrees. The tangent of 45 degrees is 1. So, tangent alpha, or 45 degrees, is 1, times the adjacent side, which is the distance to the base of the building, equals the opposite side, which is the height of the building. Now, you recall from a 45-degree angle that however far you were to the flagpole, that's how high the flagpole was, if the top of the flagpole was 45 degrees from where you were standing. Same principle right here, but it works for any angle. Now that layout works perfectly well if you can figure out the exact distance to the base of your flagpole, for example. But what if you're measuring a mountain? So you're out here, and you want to measure the height of this mountain. Well, you don't have any problem finding the angle from the surface up to the top of the mountain. But here's where your problem comes in. This is our unknown right here. We also don't know that distance because that's within the mountain. We have no way of knowing that. So how are we going to figure out the height of the mountain? Well, let's have a look at something real quick. Suppose instead we have a second spot right here, and we know the distance between those two spots exactly. We also know this angle right here. Now can we figure out the height of the mountain? Now around 1000 AD, that was the question that faced Al-Biruni, who was an Arab scientist charged with finding the radius of the Earth. He had a mountain, and he needed to know how high that mountain was. He could measure angles, and he could measure distances, but he couldn't measure the distance from either of these points to the bottom of the mountain. How did he do it? Well, let's go through his mathematics. It's actually very elegant. Okay, let's start the problem off by figuring out some things that we know. I've rewritten our diagram up here. Again, here's the height of the mountain. Here's our point 1 and our point 2. That's the angle alpha, and that's the angle beta. Now, the total distance from D to B, the line segment DB, is going to be D to C plus C to B, which is actually our D right here, our little measured distance. So far, so good. The tangent of angle alpha, which is the far angle on the right, is going to be the height of the mountain over dB. Recall that tangent is the opposite over the adjacent. That's the TOA. Now, likewise, tangent at angle B is going to be the height of the mountain over DC, which is that segment of the line. So let's rewrite this a little bit and see if we can come up with some answers and solve for H, the height of the mountain. Okay, the first part of the solution requires something called algebra and being able to substitute terms and rearrange them a little bit. So let's go ahead and go over what we had. Now, originally, this entire segment, dB, equals dC plus d. We know that tan alpha equals height over dB. dB is up here. And tan beta, right there, is the height over dC. Now we can rearrange this to find different terms. So for example, dB equals h over tan alpha. See, dB we bring up, tan alpha we bring down. We end up with this expression. Likewise, dC equals h over tan beta. Here was our original expression. Little d, the distance we measured, equals dB minus dC. That's very straightforward. Now we can substitute these values in for dB and dC. So we get d equals h over tan alpha minus h over tan beta. Are you starting to see how this is going to come together? So let's go ahead and see where we are now. D, the distance we measured, equals h over tan alpha minus h over tan bravo. So what we want to do is we want to continue to work this and solve for h. So let's go ahead and do that. Now the first thing that we have to do is we have to get a common denominator. And the easiest way to do that is basically cross multiply. So let's go ahead and do that. And of course that'll make it over tan alpha times tan bravo. Now we're cooking with gas. We can take this bottom term, the denominator, and we can multiply both sides by the denominator to get rid of it. So let's go ahead and do that. We'll put it right here. Now we've got one more step that we can do. Notice that we've got an h on both those terms. So let's do this. Now, we factored out the h and just we're left with the tangents over there. Now, obviously the next step is let's get rid of this term right here. The easiest way to do that, divide both sides by it. And there's our answer. And that is how Al-Biruni measured the height of the mountain. Now in our next episode, we're going to talk about what he did with that height of the mountain to measure the radius of the Earth. So make sure you tune in for that. So this is Bob the Science Guy signing out from Northern Michigan. Thank you very much for stopping by. I hope you enjoyed this little review of trigonometry. We'll have a little bit more next week. Take care, guys.
Mama, please make them hear me, or I can't teach them anymore. This rabbit hole's too deep for me. Feel my brain getting real sore. Bob the Science Guy. Bob the Science Guy.